We saw what is increasing, decreasing functions and strictly increasing and strictly decreasing functions. Now, how do you find that the function is strictly increasing or decreasing? One of the possibilities is by using first derivative. That is, given a function, you differentiate that function with respect to, say, in this case, x. Then, looking at the nature of f prime of x, if it's greater than 0, is it equal to 0, or is it less than 0 for the given interval, we'll be able to decide if it is increasing or it is flat or decreasing function. So let me show this. You have seen this before. So this is derivative of sine. Now let's look at the function first. The function here on the left extreme, it is reducing, it's becoming flat and then increasing, then becoming flat and reducing. So I have to show this behavior, right? The behavior of the function, how it is reducing, how it is increasing, where is it flat, using another graph, right? How will I do that? So I have to take up a tangent, draw the tangent for each of this point, like over here. Corresponding x coordinate, we need to plot the value of the slope. So if I do this, right, for example over here it was almost flat, right? And you can see over here, okay, on the second graph, that is, it is passing the x coordinate, x axis, not coordinate, x axis, means the graph is getting flatter. Now we can see on the slope side, and the slope values also can be seen at the bottom, right? Slope value is 0. Now if I continue to play, we can see that the slope will be positive, and so your differential function on the right hand side will also have positive values. Can you see that? So those are your positive values. See, all that is positive values. And now the graph became almost flat, right? The slope of the tangent, that is, it becomes almost flat. Again, we can see the graph is crossing your x-axis, and post that it is reducing, so you'll get negative value on f prime of x. So basically derivative of sine of x is cos of x, so cos of x can show this behavior. That's the whole funda, right? So derivative of a function can always help us look at this. So we can observe all of this again over here too. So this is strictly increasing. Again, if you observe, this is strictly increasing, remember. So all these values are positive. So your f of x versus x graph can have any negative, positive values. As you can see on the left extreme, we have negative values, and as in when you go, it will move on to the positive quadrant. But when it comes to derivative, we can see clearly that first and the second quadrant is where the graphs lies in. Okay, so the derivative of a function will be always a positive value, right? Please observe that. Please observe that the derivative function graph is always above 0, that is above the x-axis. Do you guys agree? It's always above the x-axis. Can you see that? So it's almost going to touch, and after that, right, there's a gap, and after that it is again increasing. Point is, it has to be positive. Doesn't matter how the behavior is. Yes, the behavior here is, it's decreasing and increasing, all that, it doesn't matter. Is the value positive or negative is the question. All these values are positive. That's it. There's no other discussion. When it comes to strictly decreasing, all the values of the derivative is always negative. Yeah, here it looks to be very close to 0, but you guys know that because the graph is from 0 to minus 60,000. So any value like in your tens or ones or hundreds, it's going to look like as if it's touching the x-axis. It is not though, right? All these values are negative. How negative it is, that is not the question, but it is negative. That's all. This is what you guys have to keep in mind, right? you don't have to bother about how negative or positive it is. So note, don't look into how positive or negative the values are. What matters is it positive or is it negative? That's all you guys have to look for. Now let's start off with an official introduction to what we are discussing. Let f be a continuous on a and b. I hope you guys understand what is continuous. So there is no breakage and we can draw the graph from a to b without lifting the pen. The differentiable on the open interval and differentiable too between a and b. An open interval. So here it is closed interval, here it is open interval. F is strictly increasing in a to b if f prime of x exists and it's greater than 0 for each value between a and b. So something like this. So we have seen this. So the graph of this will be positive value, right? Graph of f prime of x, that is, will be positive here. It's always greater than 0. Next, point B. Now, strictly decreasing has to do with f prime of x is less than 0. No question about it. So if the function is continuous between a and b, including a and b, and if the derivative exists between the open interval of a and b, then the graph will look like this. And finally, when we have the function to be constant, then the slope is 0. Okay, so slope of this is 0. You guys understand why is it, right? So these are all the things that you guys have to keep in mind. So you can summarize on your own. So I don't want to tell what to write and what not to write over here. So put the heading and do summarize this, because this is the fundamental methodology that we are going to use in solving the questions.